channel BK Tech. So today we are going to solve the problem which is the rotten oranges. So what we are going to do in this problem is that first of all, like we are given with the grid in this.
Let's say this is the grid, and there are 0, 1, 2, 0, 1, 2, 2, 1, 1. So this is the matrix we are given as an input in this. So, and one here denoted as a fresh orange, 2 denote us as a rotten oranges, and 0 denote here as a empty cell. So for solving this problem, so what we need to do is that we need to find out that how much time it will take to make the all the oranges present in this matrix rotten. So for this, what we can do is that we can apply here BFS algorithm. So what BFS is going to do is that we can with before going to the BFS, let me tell you that here we can use it that, as a one all the ones, we can collect all the ones as a fresh, that how many fresh oranges we are having, and we can know that how many rotten oranges we are having. So for this, what I can do is that as given in the question, that we need to move in only in the 4 directions. So like if we can identify that where is the first rotten oranges is present, so with the help of for loop, if I am able to identify that here is the rotten oranges present, so by going into the 4 direction to its neighbor, I can identify that where the fresh oranges are present. So by this, with the help of this, I can keep it this as a 0, the time taken here as a 0. Then when it goes to this one, time increased by t equal to 1. When the we go to this one, the time will be this, we won't be going to this element because it is already 2. So after going to this one, as the time has increased, then we are going to check that at this element who are having the neighbor of this. So if you see this at this neighbor of this one, 1 is present, so we are going to come to this, and the time will get increased by t equal to 2. And in the same way, we are going to go to the next neighbor and see if the 1 is present. So you can see that here the 1 is present, so the time will be increased by again by t equal to 3. And in the same way, we can go to this element, but time will increase by 4. But this will only happen if you start from the this element and ignore the other two. But what happens, like if you make the matrix 0 1 2 0 1 2 2 1 1, the thing is ki this one is nearest to this one, this one is nearest to this one, and this one is also nearest to this one, and this one is also nearest to this one. So I said that we are applying the BFS algorithm. So what we are going to do is that we are going to keep one queue here. Here we are going to store all the indices where the 2 is present. So here you can see that at indices 0 comma 3 the 2 is present, at 1 comma 3 2 is present, and 3 comma 1 uh, 2 is present. So we are going to put all the 2 in this queue. Once all these 2 are present in that, then we are going to apply a while loop where we are going to put all the elements out of the queue. Means we are going to pick we are going to it traverse on the queue until the queue is empty. So queue dot is empty, and see that who are the neighbors if it so if you pick out the 3 comma 1, if you pick out the 3 like this one, so we can see that the neighbor of this is the this one. So this will be converted to 2 comma 1, and this is the means the time taken by this element will be the it, this is having a t equal to 0, so this will be having a t equal to 1 now, because coming to this element will increase the time of this. And then we can see that, and in the same way, at the same time, this 2 will convert this 1 as a 2, and in the same way time, this 2 is will be converting this to 1 in the same 2 in the t equal to 1 time. So after this, there will be no one left, so we won't be able to traverse much more. So the maximum time required will be equal to 1 for this question. Let's now come to the solving part of this problem in the GFG.
So now coming to the coding part of this problem. So if you see, we are given with the one grid as an input. So here the we are given with the input matrix. So first what we are going to do is that we are going to create one queue which store a pair as an object, and this will be of linked list type. And as the it is storing a pair, so we need to create one class also. So class, and we are going to create for the class we are going to take as a row, then a column, then we need a three parameters in this: row, column, and a time. So after this we are going to put we are going to filter out that wherever 2 is present in our matrix. So we are going to create one for loop to traverse the matrix, and we need a size of the grid also for traversing it. So we are going to store our size in n grid dot length, and we are going to get the size of our columns also. So how many columns we'll be having? So grid 0 dot length. So we are having n rows, and we will be having a n columns. Here we are going to put one if condition which is going to check that uh, how many 2 are present in our uh, matrix. If it is equal to 2, it will go inside the our if condition, and we are going to put this into our queue. I will be the row, j will be the column, and time will be, right now it will be 0 because we are starting from the 2 only. Else we also need to maintain one visited array in this, and wherever we are visiting a 2, we are going to mark that as a visited. Else we are going to not mark it as a visited, and we are going to store 0 in that only. So well, by default generally array stores 0 only, and we are going to also keep one if condition which will keep a count that how many fresh oranges we are having. So whenever we found any one, we are going to increase the count of our fresh orange. So we have extracted our number of fresh oranges, and we have also extracted the how many rotten oranges we have, and we have put them into the queue. So now we have given that we can move in the 4 direction for this question. So we are going to create one delta row and delta column as we did in the number of island and number of uh, provinces wala problem. You can watch them in my playlist of graph. So now delta row and delta column is created. So now we are going to traverse our queue until it is empty. Once After creating the while loop, we are going to extract the peak element from this. So int row equal to q dot peak dot row, column equals to q dot peak dot column, and int time equal to q dot peak dot time. Once we got the row, column, and time, we are going to go into the 4 direction of from that row column, from that node, or you can say. So int I equal to 0. I should be less than equal to 4 because we can go at the maximum of 4 direction. Then n row should be equals to row plus del row. Once we have uh, calculated above our delta column and delta row, or you can say the neighbor row and column, we need to check that if they are in the permissible limit or not, means they are not going out of bound. So n row should be less than equals to 0, should, sorry, greater than equal to 0, and n column should be also greater than equal to 0, and n row should be less than n, and n column should be less than m, and should be equals to 1 only. Otherwise we don't need to go into that, because if it is empty we don't need to put that into our queue, and it should not be visited. And only we are going to go into this queue, and we are also going to maintain the maximum time for this, because we are calculating the time only in this. Max time right now is equal to 0. So if this condition matches, then we are going to put our this n row into this neighbor into our queue. Otherwise we are not going to put into our queue, and time will be increased by 1 for this. And we are also going to mark this as a visited, and we are also going to check if time is greater than max time. Then we are going to replace max time with our current time, and we are also going to increase, we are also going to maintain that how many fresh oranges we are able to convert it to the rotten oranges. So we are going to keep the count of fresh oranges in the queue. Out now, right now it will be 0, and whenever we satisfy this if condition, we are going to increase that. And in the last, if count of fresh oranges is not equal to what we calculated above, then we are going to return -1. Otherwise we are going to return maximum time. Now we can compile this code. So I can see there was a problem. Q dot add new. Okay, so first of all, though, we also need to add here new pair, and we also need to modify this to pair. And let me check if pair is in the, yeah, pair is in the, p is always in the capital because p is a class. So we can modify it here. Yeah, it is correct here. Now we can come. So now it has passed the test case for us. So now we can submit this code. And you can see all the test cases are passed. So thank you for joining. You can wait for my next video. Thanks. Bye.